If a primary system is being attacked, the whole goal of the adversary may be to start outputting bad measurements. Everybody in the audience, this answer is unclassified because I'm not currently cleared for any of this work. This stuff, even in an unclassified, just from a corporate protection, man, they're not compelled, right? A space operator is not compelled the same way that your bank is to tell you that they had a breach. I think it's very safe to say there's 10 other satellites out there that are infected with this right now and just don't know, right?
How often does that sort of thing happen?
Mm.
And is most of that sort of thing coming from the ground, or is there actually interceptors that are doing that stuff already?
You really can't ignore it, right? Everything else that it jumps up over the top of, it really does become secondary now because you're being hacked. So really the answer is
Welcome, everybody, to Tomorrow. I am SpaceMIke, and I am joined today by Dick Wilkinson from ProofLabs Space. We're going to have a really good conversation today about cybersecurity, hacking into satellites, and how to protect the satellites from bad actors from doing that sort of thing. You guys have a really interesting system that we're going to talk about in depth called CROO. But before we get to that sort of stuff, we would like to know a little bit more about you and your story and how you ended up in this industry and in this space. We talked a little bit earlier off camera about how you started with the Army and kind of had a little happy accident to get involved with us. So
yeah.
can you tell us that again and tell us a bit more about how you ended up here?
Yeah. Thank you for having me, Mike, and thanks for hosting the show. I'm glad to be a part of it today. The background for me and how did Dick, become a co-founder of a space company and get to what we're talking about today. I was very interested in space as a kid, but I didn't see myself necessarily ending up in a career that would get me into the space industry. As I got into high school, I realized math was a big part of astronomy and astrophysics, and I didn't enjoy math. I was good at it, but I didn't want that to be my job. And so I ended up joining the Army when I was 18 years old, and I was an intelligence guy. Didn't think that there'd be anything space related to that work. And then after my first duty assignment, which was at Fort Meade, Maryland, at the NSA headquarters, I got an opportunity to volunteer for something. And it was a situation where the location was cool, but the work was not well defined or described. And so I volunteered to go to a location because other people didn't want to go there. And I figured out that in the Army or in the military in general, if you volunteer for like the stuff on the edge cases, the weird kind of out of the norm stuff, you're probably setting yourself up for some kind of success if you think if you feel like you're going to be comfortable there. And so I volunteered and ended up in a space assignment. And I found that out the day that I walked into the ops floor. And they said, basically pulled the sheet off and said, "Congratulations, you're a space operator now." And that was complete fluke as far as I was concerned. But once I got that opportunity, I stayed with it. And I spent 7 years of my 20 years in the Army working directly on satellite missions. And then I had another 5+ years evaluating cyber effects and radio frequency effects that had to do with space technology in a lab for the Secretary of Defense down at Kirtland Air Force Base in New Mexico, and that was
Oh,
kind of the
wow.
end of my career. So that's the span from accidentally volunteering for a space mission to being an evaluator and an auditor of space equipment.
Can you tell us about any of those satellites? Are you allowed to talk about them? Are there any that the general public might have heard of? Like, did you work on like any of the MUOS satellites or TDRS or anything like that?
I in my primary, when I say I was a satellite operator, those were classified missions that there wouldn't be much information out there about. As a ground customer, I was a customer of the Trojan network, which is the Army's tactical data and kind of field station relay network. And so I was assigned into a unit where we would collect intelligence on the ground, and then we needed to use the Trojan network. And we had a big Humvee with a dish that folded up off the top of it, and then we would acquire the satellite and get connected. So I got to use the subscriber end equipment there, where we would set up the dish, get the network connected, and turn on the satellite modem, load the encryption, and see how the actual that segment worked. So that was my exposure on the less classified side of satellite use.
Awesome. Very cool. So after you left the army, did you go immediately into being one of the co-founders of Proof Labs, or did you do any other space related stuff before this?
Thanks for asking this question. The My goal when I left the army was no government ever again. Right? I've done it for 20 years. The only way I'll work for or in the government is if I'm an elected official, meaning basically that I don't want to be in the bureaucracy. I don't want to be beholden to it, and so I don't want to be. I don't want to suffer from bureaucracy. I want to execute bureaucracy, I guess. Right? so um, I fell all the way from the federal branch on the tree down to the state level. And I worked for the state of New Mexico for 3 years when I retired,
Okay.
doing chief information security officer work for the judicial branch. And then I became the chief technology officer for the judicial branch of the state and started the company while I was working in that role. And actually dual hatted for a little while, doing business development stuff for the first year or so within the company before I separated from the state. So and here we are back to selling to the DoD, and the vortex just continues, right? Where the government, from a cyber perspective, security perspective, like it makes sense. They do the most, development. They spend the most money. They have the most assets to protect. So it's an unavoidable part of the job, and that's fine. I still get to have a beard and decide when I go to work. So I'm not in the army, and I guess that's what I really wanted.
So when did you start Proof Labs?
We incorporated in 2021,
Okay.
in March of 2021. We're an S Corp in Delaware. But we got started doing our business development and our exploratory work about a year before that. So we're almost 5 years deep on the overall project, but we've been incorporated for 4 years now.
Okay. Well, let's talk about what it is that you guys do. I mean, just doing a little bit of research from what I can tell, it's pretty much all cybersecurity stuff. And you guys have this program called CROO, CROO. What does
Mhm,
that stand for? And, give us the pitch of what exactly it is that you guys do and how this helps the space industry.
mhm. Well, I'll start with the non-technical piece and the more interesting story. I think the storytelling piece, and then maybe the technology is interesting. I'm not sure, but why Crow? Why did we name this program Crow? There's some inspiration there that's more than just an acronym. But in the military, if you can't make an acronym out of it, it'll never be a program of record. Like that's just it's not possible, right? You must have acronyms. So we understood that. I definitely understood that and knew that the cooler the name, the like more attention you might get. So I came up with the name crow because the actual animal, the bird, goes. It serves a purpose in nature that's very similar to what we are building. Crows can fly up to the top of the trees. They observe the landscape around them. They give early warnings to other animals that aren't crows, that aren't just birds, and they are sort of a watchdog in the sky that effectively communicates and keeps other animals safe. So, what we're building is software that can be in the satellite itself and can monitor the activity that's going on within a satellite and be able to create an alarm that tells not only that satellite operator how to protect the other satellites that they own and operate that may need protection in the very immediate term, but we can also have a threat intelligence feed that shares that information just like the actual animal does with the rest of the environment, right? Let's tell other space operators, let's tell other government interest kind of organizations that need to know this stuff that there's threat intelligence available and we can develop indicators of compromise and behaviors of compromise to describe what you can do to protect your own assets. So really, I like sharing that the inspiration of crow is really based on the actual natural role that the bird plays in nature. And we're creating some of that same goodness within our architecture as well.
So, would I have this right to say that if you guys detect something, you can let other satellite operators know, hey, we're getting this type of signal. It's coming from these frequencies. Here's where it's coming from. Watch out if you don't have anything ready. That be safe
Yeah.
to say that that's something that. And a question that I do have is if they don't have some stuff set up. When they have actually done their launch, is there a
Mhm.
software update that they can do to add that service on later?
Mhm. So good, that's a good segue into some of the more technical elements of what we're building. One thing to be clear about that right now we're in a direct to phase two development program for the Space Force, and we are specifically delivering telemetry anomaly detection. Right. So those words, when you put them together, it sounds like a tongue twister. But really, we're watching on board the spacecraft. We can sense telemetry, meaning different parts of the spacecraft communicating with other electronic components on the bird, and its internal. Think like your own vehicle. A car on the road has a computer system in it. And that computer system is telling both the user and other parts of the car everything that's performing correctly or incorrectly right now. Satellites have the exact same type of telemetry on them and sometimes even use the same format as vehicles on the road. And so that methodology of one part telling another part, I'm operating correctly and I'm in tolerance, there's a lot of inference that you can do there. And from a cybersecurity perspective, sensing is really the issue when you're talking about on board events. What part of the satellite do I need to watch? What exactly am I concerned with from a communication perspective or a performance perspective to know that something is a trigger or is that a normal activity? And so, what we've started with as step one of what we're delivering is telemetry monitoring and being able to say this behavior change for this device is normal under these other conditions, or this behavior change for this part of the satellite does not conform. And that non-conformance is where we're going to throw an alarm and say, hey, satellite operator, some part of your satellite is behaving in a way that we can classify as the beginning of an infiltration of your satellite. And so we want to tell you as early as we can in the kill chain that when this piece of equipment starts to behave out of tolerance, that's something you need to be very concerned with, because the next thing that's going to happen is probably this. And so that's really what we're doing, is watching those telemetry onboard communications right now, and understanding that behavior as to whether it's normal or anomalous. To follow on to your question, though, about can we do this post event? Can we do this post launch? Can we cover satellites and legacy systems that are even well past their design life? And the short answer there is yes. We do not right now. We understand that there's multiple ways to deploy this service. We can deploy all the way in, all the way right up to basically the flight software on the satellite. And if there's compute space available, then we'd be able to operate there even on a legacy system. But the good news is that we're designing this so that we'll also always be able to work in a cloud environment to where we don't have to run directly on your asset, because a lot of satellites don't have the additional capacity to take something, especially post launch, and run additional computer needs inside of that environment. So we understand that you may have to export the data over to us, but then we can run in a less resource constrained environment and sense your data, do our we're going to say AI. We are using AI, but that's not, I'm not putting a buzzword out there, but we're going to do our machine learning and AI algorithms in a less resource constrained environment. We've got ways to kind of ebb and flow that into the bird or off the bird, depending on, what you've got available. So legacy systems are within scope for us.
Does that help you to kind of identify any sort of false positives? And to kind of related to that, do you guys get any sort of alerts for things that are natural phenomena like electromagnetic interference from like solar flares or something like that?
Mm-hmm. So that is a big part of the work and discovery that we're doing right now, is and the problem set that we're, the problem statement that we're trying to solve is that a lot of satellite operators will get anomalous behavior, but not have a way to classify it. They just know that something is not performing the way it used to, whether it's the battery, the solar panel, the flight computer, the actual radio that talks up and down to the earth. They're getting a problem, but they can't classify the problem. So it requires the whole team, the brain trust of engineers for that satellite network, all have to kind of confer and come together and do a big investigation into what is this, what's the root cause of this problem, and how do we classify it, and then how can we fix it, right? That process can take weeks. And depending on the sensitivity of your mission and the responsiveness of your mission, you don't really have weeks. And then the way spacecraft are designed, if it's impacting something that keeps your spacecraft running, again, you don't have weeks to recover this problem. Your spacecraft can die on orbit. So our goal is to help those satellite operators classify: is this space weather? Is it a mechanical failure? Or is it a human intrusion? Right now, the first two are the main categories that they're going to investigate. Is it mechanical failure or is it space weather? And there's some methodologies, if you will, from an engineering perspective on how to tease apart the two. But we'd like to have our AI system not, you don't have to worry about the engineer understanding every methodology to pull these things apart. AI is going to classify it for you, and it's going to give you a very high confidence answer as to, hey, this was space weather associated, does not indicate human compromise. Or, we understand just based on everything else that there's not a space weather component happening right now. This is mimicking a failure that would be associated with space weather, but that's not what's going on. And we can help you tease those two answers apart.
That's really cool. That's really cool. That helps a lot. Actually makes me wonder, has your guys' CROO system already been deployed on several satellites, or is this still in the works?
Still in the works. Still looking for folks that are either on orbit right now, or especially, satellites that are in the design phase that understand they want to start building in budget, if you will, swap budget, space and weight and power availability for additional software, or even if we needed to, an additional hardware chip with a little bit of weight associated with it. There's different kind of tolerances available there. So we're still in development, and we're looking at making sure that as we get ready for full deployment, that can happen totally weightless as a software deployment, or we can have a plug and play module so that people that are building these small CubeSats and modular study based type CubeSats, where they're not reinventing every piece, that they could take something off the shelf, plug it in, and get that level of antivirus onboard protection that otherwise they'd have to do a lot of engineering. We want to lower that engineering lift and make it really easy. You can do it software, you can do it hardware, but we want to make sure that our integration is very easy for the end user.
That is great. That is great. Actually, I already have a couple of questions from the chat room that I would like
Mhm.
to get to. Um, this is a good one from Sakura's Light. Can you detect motion of the device or external electromagnetic mass detection, gravitational waves, that type of thing?
Mhm. Mhm. So our goal is, if a primary system is being attacked, the whole goal of the adversary may be to start outputting bad measurements. They may want you to have some kind of sensor on board start to just give out bad information, and then that would confuse other sensors. And so our language within our research right now is that we're looking for side channel indicators of compromise. The primary system that's under attack is almost guaranteed to give off telemetric changes, right? But what we want to look at is every other subsystem in the satellite. How, if someone figures out how to make a stealthy attack happen on the primary system, you're still going to have these kind of perturbations, if you will, around other aspects of the satellite. And those little indicators are what we're looking for. So, yes, we're looking at basically any kind of output that any other system on board can give into the overall decision matrix, if you will, how they're always giving different inputs into what is right. Am I oriented correctly? Am I still on the right path? Do I have enough power to complete my mission? Those are all kind of different equations that are always running. And we want to make sure that we're sensing all of the different inputs into those equations so that if any of them start to drift, we can identify that as a change. So I think my answer to your audience member there is yes, we can start to take in input when any other sensor is impacted by something that's not on board the satellite. Now, those are going to be very minute changes. Stealth attacks that are doing things like magnetic waves against the satellite, those would be very small input wise. But if they impact several different pieces of the satellite all around the same time, well, guess what? That's going to be a huge tripwire for a system like ours, where if two or three different systems start to move out of tolerance at the same time, even if they don't seem orchestrated together, the time barrier of that gate is going to get, a huge red flag is going to get thrown. So yes, we would be able to start to see rendezvous type events where someone shows up and starts washing your spacecraft with microwave energy, or starts trying to draw it in with a magnet. As things start to change and your reaction wheel or orientation system start to change, we'd know about that right away. Yeah.
How often does that sort of thing happen?
Mm.
And is most of that sort of thing coming from the ground, or is there actually interceptors that are doing that stuff already? I know there's a lot of talk about it hypothetically, but
Mhm.
how much of that is actually happening
Mhm.
today?
Well, I'll share with everybody in the audience. This answer is unclassified because I'm not currently cleared for any of this work. In my previous life, I was, but I haven't had a clearance in a few years. So my answers now are based on my exposure through the organization that I'm a member of, the Space Information Sharing and Analysis Center. I'm at that facility now, and ProofLabs operates out of the Cyber Vulnerability Lab here. So really, it's hard to answer this question without addressing our relationship with this group. There's an ops floor just on the other side of the wall from me here. It's not 24/7, but globally there are other ops floors that are connected to this. There's one in Japan and there's one in Australia, and then there's Europe and there's here. All four or five different organizations worldwide kind of have a sun never sets on an ops floor layout. So we almost have 24/7 coverage from the industry. This is not government, but industry watch floor that says what kind of activities are happening in space on the ground, from classic like ransomware threats that may be pointed at a aerospace company to something that's more specific to a targeted type of campaign, all the way through to someone attacking operational technology. That's what this ops floor is for. And so ProofLabs has been a member here for a few years, and we are developing this because the whole apparatus here will be very happy and quick to highlight that what they can sense on orbit is extremely limited. Most of what they can report on, most of what they can read about or learn about from other sources is terrestrial based attacks. Then you have quite a bit of a rich data set around the radio frequency and the uplink, downlink, the link segment. There's a lot of understanding there, both in the commercial perspective and a government perspective. There's a lot of protection happening there. But once you get up to, being out there on orbit and you start talking about bird to bird communications, the cross links, you start talking about on orbit edge resources where computing is going to be happening in space and payloads of data don't come all the way down to the ground. There's a gap there. There's a huge intelligence gap for what exists on orbit right now. And so the issue is, who can say clearly how much these types of attacks happen? We have to rely on the drips and drabs of companies that publicly acknowledge that they had some kind of interference with their satellite network, right? This stuff, even in an unclassified, just from a corporate protection, man, they're not compelled, right? A space operator
Yeah.
is not compelled the same way that your bank is to tell you that they had a breach, because
Yeah.
it's just not the same industry, right? And so there's a lot of activity that doesn't get reported. It gets handled internally, it gets remediated internally, and never makes it even over to this industry consortium here. So really the answer is, who knows how much is happening on orbit, right? But the good answer that we do have is that there have been, in the last few years, nation state attacks on commercial networks that have been publicized, right? We're aware of Russia's activity against commercial operators in the Ukraine conflict. But there's also been recently, last year, I'll mention something that there's almost no reporting on. There's a new topic that came out just in the last few weeks, and there's been very little reporting on it. But I want to say the name here, and most people won't have heard of it. It's called Orbit Shade. Orbit Shade was the name of the attack method or the malware, and that name was offered by Mandiant. Mandiant they didn't write, like, there's not a public report on this. I saw a third party report mentioning a Mandiant researcher, but the third party report was very valid, and I felt like it had high credibility because it had an example of the attack um, kind of command sequence in this report. That happened in the end of last calendar year, beginning of this calendar year, where there were several different satellite operators that were already customers of Mandiant that reported cyber concerns. Well, as Mandiant investigated it, they found that there were some man in the middle attacks happening within these networks that were exploiting the delay in time to the satellite transmission and getting their man in the middle attack implanted in that delay path. And then they were able to overwrite firmware and make persistent implants. There was at least four satellite operators that have Mandiant as a their go to, right, a consultant or their incident response people, something like that, right. And so that's one company, Mandiant, being kind of the focal point there for just the operators that have a hotline to them. That's a very, very small footprint, right? So the idea that those four people or those four operators are the only ones that ever were impacted by that's unrealistic, right? If there's four that had somebody to call and they got the investigation done, I think it's very safe to say there's 10 other satellites out there that are infected with this right now and just don't know, right? They don't know. And the proof is in the pudding that the man in the middle attack was pretty elegant, and so it's very realistic to believe that there are a lot of other instances of just this one attack that exists right now in the wild and just haven't been investigated. So
Wow.
we're doing some development in the lab with our software development right now and making sure that the attack method that was used in Orbit Shade is represented in our testing, so that we can kind of prove that we have a detection that can identify when this type of traffic starts to happen. And of course, it's as bad as it could be, right? You got firmware issues, right? If something gets overwritten in firmware, the whole asset is basically owned at that point. And then there was proof that they were, as kind of the nightmare of a commercial operator, siphoning bandwidth, right? Everything in space is all about every bit is worth money, right? And so they're siphoning bandwidth off your satellite links and taking it away from paid customers. That's like the nightmare for a commercial operator. Just as bad as losing your asset is losing some of your bandwidth and not knowing how to get it back, right? So that's recent, and that's just one little insight into the
Wow.
type of activity that's out here on the unclassified side of the world. So
Wow. I'm completely unfamiliar with that. I hadn't heard about that at all. Were they ever able to figure out where the source of this was?
Mandiant may have. It wasn't in the article that I read, and I am, trying my best to try and get more information about this. So, anybody in the audience, anybody from Mandiant that knows what I'm talking about, I haven't started knocking doors or doing any of the gumshoe work of really tracking down people that I think are associated with the investigation. But the description that was in the news report that I read gave me enough that I could get into the lab and start, building some detections and countermeasures against it. So,
Wow. So yeah, that answers my question. This type of stuff actually does happen a lot more often than what people are aware of. I mean, the only time that it ever comes across my desk is when, it's confirmed that this is something from Russia or China and they have somebody to blame for it.
mhm.
But man, I had
Well,
no
and
idea.
I'll highlight one that, for the researchers out there, that if someone wants to do even personal dabbling, you can do this. Core flight software is available from NASA, and it is actually used in, there's a lot of satellites on orbit right now that have core flight as their main operating system for their satellite. It's public. It's an academic project. It's got some published vulnerabilities, and there are a lot of different written out and proven attack methods that exist within core flight. And some of them are just as basic as there's not authentication on the uplinks. And so if you can get your transmission out to space, the chances of you getting in contact with a satellite that's flying core flight and it will accept your commands, it's about as good as going fishing at your local park, right? Like eventually you are going to catch something, right? And that's just again an unclassified open source software out there, published vulnerabilities, published attack methods, and it's just I guess there's the nation states don't see going after that as worth doing, right? And then the hobby people understand that if I crash a satellite or interfere with some academic research that costs $500 million to do, well, that's a level of risk I don't want to take. But the technology, the risk, and the access is there. It's just sitting there, right? It's other factors that are stopping it from happening, not the technology. That's not stopping bad things from happening.
Wow. Wow. That's so crazy to think about. And actually related, you did kind of already answer this, but I did want to ask this question from the chat room. Colton asks, was going to ask if there is a problem like a bit shift that does that suddenly make a security opening, and how would you deal with that? For example, number one and two leading to an opening in number three.
Mhm. Spacecraft and the communication systems that talk back and forth to spacecraft, either from the ground up or from bird to bird, which is becoming more popular, it is an operational tech communication path. So it's not built exactly like your classic TCP IP networks that all your terrestrial based communications happen. Once you get to the satellite modem, there's a lot of different bit manipulation and management that happens there because there are issues with getting your transmissions up and down to space with perfect, perfect bit rates. You're not going to get perfect bit throughput. So the answer to the audience member's question there is that um, there's overhead bits, there's correctional bits, and then there's these schemes that are built on top of all of that to do all this automatic error correction. So there's a lot of at the, we'll call it networking layer, if you will, the OT networking layer, there's a lot of multi-layered safety nets, but it's not about security so much as it is about performance, right? Can I drop some bits and keep my packet stream going? Do I lose my subscribers and have to reacquire everybody? Or does everybody kind of hang on for the next clean packet and then they can get back in line and keep things going? And how do we deal with that error correction? So the functionality leads to tools and kind of methods that we can use to do security with those bit error rate functionality, right? So the answer there is that there's a lot of tolerance built into these networks that it takes a little bit more than a bad connection to be able to slip in and sort of start to masquerade. You also have to be able to finesse the error correction or the other bit authentication schemes that are in there. So even if the main user who's like talking on the phone, if their phone call is not encrypted, the package of overall data stream that it got put into is probably still encrypted over the top of that. So, there's defense in depth that's actually delivered by functionality in depth. Weird way to say
Got
that,
it.
but that's what it is.
Got it. And that actually, they followed up on that a bit, saying that they were more concerned about, say, a bit flip in some encryption decryption function in the firmware
Mhm.
that would allow, say, a wrong key to be accepted when it comes to secured systems on a craft. So,
That is an attack. That is an attack surface that is not as tight and hardened as it could be versus what happens on the ground. And the reason for that is certain tolerances again are engineered in so that it doesn't take 15 different passes of, it didn't work. Oh, every single thing didn't get through perfectly. So the key's not uploaded. So now we have to wait 2 hours for it to come back around and try again. And then, oh, that one didn't work. So now we're going to do it again. There are queues, there are little check bits in there that allow for little bits of errors. So yes, there is an attack surface issue more on that side of like encryption keys and whether or not something will accept, or if it thinks that the encryption is done being loaded, like, is it really done? Or is there something left that it just accepted it? And now the actual encryption check just doesn't happen. And the whole system turns green, but it only got 3/4 of the key. And now it just doesn't do the thing that it thinks it's doing until the next time you try to upload a key, maybe a few days or weeks later, and you change your material, and then you actually get the right key installed, and then it starts working again. Sure, there's opportunities there where things can default back into unencrypted mode and just operate that way until they get something that puts them into a better status where they go back into encrypted mode. And absolutely, there are operators out there that wouldn't necessarily notice if that happened. If bits are going through, we're making money. That's it. So yes, that is a concern.
is there any sort of like, is there a lot of accidental frequency jumping where people are sending signals to something else and it gets received by satellites that they didn't intend for it to go to?
Mhm. I wouldn't say too much on definitely not accidents on the uplinks and downlinks very often because they are so orchestrated from a frequency management angle. Think, if a U.S. satellite operator wants to fly, they have to get approval from the Federal Aviation Administration, but they also have to get approval from FCC, the Federal Communications Commission, right? And so that FCC license, it tells them exactly you have these types of equipment and they are authorized to work on these bands because that's what you paid for. And if you start to transmit into other bands, you can be fined or your whole license can be revoked because you're stepping on someone else's bandwidth and they paid for that. So accidents, very rare. Um, Nation states doing things that could be described as an accident to probe and to loiter and to interfere, well, that probably happens quite a bit, right? And so a lot of times things that are kind of rubbed out off as accidents, like, oh, don't worry about it, and just poo-pooed away, was really more of an intelligent scoping operation, to see what will people tolerate, what will people turn their system off when this happens, right? And then everybody just goes, oh, oops, accident. That was an accident. We thought we were pointing south, but we were pointing north. Those things do happen. Yeah.
Uh-huh, sure.
Yeah.
Interesting, interesting. Well, let's get back to the inter-satellite communication. This is
Mhm.
actually a really good question that Jacob asked. Can you talk a little bit about Killnet and the Starlink hack?
Okay. So, internet, inter-satellite communication is something that, if I get on a soapbox, right, if I want to talk about something that I think is interesting, I think the satellite to satellite communications is the attack surface. That if I'm the adversary, that's what I want to try. I'm going to try to start there, right? It's the back door is the thing. It's harder to get to, but if you exploit it, it's less likely to be noticed in my mind, right? It's less likely to be investigated. It's more likely to be lumped in with, oh, something's misbehaving, right? Because it's thought of as layers deep inside the satellite. And
Oh
still,
man.
which isn't not incorrect, people think ground system first. This is where your security starts, then your link layer, and then finally, like internals of the satellite. Well, bird to bird communications is tucked way off mentally in the back corner of the satellite, but it's really what could be a wide open back door. Whereas all the encryption, all of the management is put on the main communication channel, right? And the money is spent on protecting that main communication channel because people from the ground can just point up, right? And they don't have to fly a satellite to transmit some energy into space. So the barrier to entry to transmit to space is very low. The barrier to entry to do something in space is pretty high. But those bird to bird communications are, for me, those are the dangerous ones, right? It's just the playground from the hacker's perspective. So,
Wow.
thinking about the Starlink satellites is a good example of, if you can do anything to manipulate the bird to bird communications, that fleet, and I'll give SpaceX their credit where it's due. They're managing that fleet as all one big beehive, if you will, right? I mean, it really is. Entire portions of satellites can change elevation together. There's not really any other satellite fleet out there that will make a movement and say, hey, these strings of satellites, all five of these need to do something and move in coordination. That's not really a thing, definitely not on the commercial side of the house right now. And so the concern there, and what, that question of, if you can do satellite to satellite hacks or satellite to satellite communication, and you're able to send in, real commands. Well, everything now in this, the SpaceX world is self-tuning and self-correcting. So as things start to face space drag, they can elevate themselves up a little bit and overcome that drag within their fuel tolerance. So now the adversary gets to do something where they don't just impact one or two satellites, or even just that string of satellites. If there's like 10 of them in a SpaceX string, they can actually impact the entire fleet. Because if you make one of them change, everybody else is going to try and self correct to keep their look angles. If this one's too high and that bird to bird communication, now I'm flying 100 miles or 20 miles up in elevation. Maybe I can't point down to something that's at a lower elevation. So now everything else is going to raise up to keep it at eye level, if you will. Think space eye level. And
Yeah.
so changing one piece of the satellite architecture can impact all the satellites in that architecture. Everything that SpaceX does to push the envelope of better management is going to also expose the envelope of, threats and impacts. So they're just the unfortunate guinea pig of proving what can work, but also proving what can be really dangerous, right?
Sure.
Yeah.
Wow. You've definitely helped me to understand a lot more of why the Space Force, especially, is worried about this kind of stuff. I
Hmm.
hadn't considered at all how it might be a lot easier to get in a back door by having something that's on orbit that way.
Hmm.
Man, okay, that's making a lot more sense.
Yeah, I'll offer something there that I think it's coming soon. I mean, it has to happen. Aircraft and ships, they do what are called friend or foe beacon broadcast communications. So military aircraft and commercial aircraft can have what, immediate, I can't remember IFF, but it's friend or foe is what it stands for. And it's just sending out a signal that says, like, I am part of, the NATO aircraft in this region. And if you're not a NATO aircraft, you cannot tell me that you're a NATO aircraft. And on my radar, I'm going to know you're not a NATO aircraft. You're a military aircraft that's a foe, basically. You're either a friend or a foe. And all aircraft and ships have some kind of system where they can just quickly, immediately communicate friend or foe. I think these bird to bird spacecraft links are going to start to have that type of capability to where the protocol to do real data transmissions will probably look like Wi-Fi or a cellular telephone call right now, where you do some kind of handshake and then you pass off data. But there's going to be some other thing that's more generic and less authenticated, where it's just a beacon and a little call and response type thing. Are you who you think you are? Am I who I say I am? Those kind of messages. And again, with that less authentication, but must be received, must be transmitted to get your license to fly with the FAA. 10 years from now, you're going to have a friend or foe beacon on your satellite. That right there, that's my attack surface right there. If I'm the bad guy, I want to just make your friend or foe thing spit out bad traffic. I want to commandeer it and start hacking other satellites with your beacon, right? So just a little near future thought process of what's coming into this low Earth orbit, especially traffic management, is going to be a lot of device IDs and friend or foe traffic going on up there.
Wow. Yeah, I can see now why that would certainly be needed in the near future, if not as soon as possible.
Mm-hmm.
Man, especially with all these fleets that everyone is wanting to do. I mean, we've got SpaceX that will do, who knows how many they're going to get up to before
Mm-hmm.
they ever stop. We've got the Kuiper systems that are starting to come online, and then the two different Chinese systems that each are aiming for about 13,000 satellites
Yeah.
apiece. It's going to get really complicated real quick. It
Mm-hmm.
already is, but it's going to get even worse in the very near future.
Yes.
So, tell me a little bit more about the work that you have been able to do so far with Space Force. What sort of stuff have they been looking at to get you guys to work on?
Mm-hmm. Well, the Air Force Research Lab and the Space Systems Command. So we got Air Force and Space Force kind of blended together in the project that we're working on right now. ProofLabs is in a direct to phase two development project, and we're building the software that we mentioned earlier, the cyber resilient on orbit. The focus there is that the Air Force has recognized that I guess there's no more time for delay on building antivirus and on orbit protection and link budget protection that so far has been a lot of risk has been accepted in that area is really what it comes down to. And so the idea that you needed to protect a subsystem within your spacecraft was just, protect the whole spacecraft and then the subsystem will be fine. That's not really an acceptable level of kind of protection anymore from the Space Force's perspective. They want to move more towards zero trust level granularity, right? We want to know every communication that comes in. There's no perimeter anymore. We can't think of a satellite as a safe perimeter. We need to get further into the operations of the satellite to understand that everything is operating safely. And something that I think is really it's been going on for a little while, but it's going to continue to proliferate. One rocket can now carry a bunch of satellites up to space, whereas it used to be a one-to-one linkage, right? Basically, you put one big old satellite on top of one big rocket, and that was it. That was the trip up. Well, now you got one rocket carries multiple satellites. Now you've also got one satellite carries multiple customer payloads, right? So there's one satellite that goes out to one place in space or flies in one path, but there's four different organizations that have sensors on there. They don't all work together, right? Those four organizations are not coordinated. They don't, my sensor that's taking pictures in this spectral imaging, need has nothing to do with what you're doing with this other piece of radar equipment. And then this one looks out at the stars. It doesn't even look at the Earth. It looks in the other direction. That blended environment means that their perimeter idea of a satellite is gone, right? Because any one of those payloads could be a target, and then the other ones become collateral damage because that other high priority thing that the enemy cared about knocked off, these other sensors. So the proliferation of more satellites per rocket and then more payloads per satellite means that stovepiped concept of security could be taken care of all the way down at like the ground level satellite modem. That's just gone now. And so that's really the change in landscape for us. The proliferation is not just in number of satellites, but in the design and build and sort of logistical operations of how payloads get to where they're going.
Wow. Man, I had not even considered that. I've been a big fan of this sort of collaboration for a while now, and I've loved to see all these different operators working on the same satellite, or of course, multiple satellites from different operators on the same launch. But I hadn't even considered that your instrument might be a vulnerability for not only the rest of the instruments on board, but for the
Mhm.
entire satellite or even the entire network that it might
Mhm.
be on. Oh my gosh!
Yeah. Yep.
Wow.
So there's no stovepipes anymore, right? I mean, from here forward, things that are getting launched are not getting launched as point to point or just a bent pipe. That's really not going to happen in space anymore. It's just too expensive to do it that way. And so even classified missions are co-opting one satellite to do two or three classified missions together because it's just from a logistics perspective, it makes more sense. So
Yeah. But yeah, that obviously brings up the need for more, communication, making sure that everyone's on the same page and working together to eliminate those vulnerabilities.
yeah.
Man,
But I'll say, to be more responsive on the question with the Space Force and Air Force, the overall tolerance, as of what I was talking about, the risk acceptance of those things that they felt like were safe behind the walled garden of the satellite or just being out in space, that mentality is gone. I feel like it's pretty thoroughly gone, which is good, right? And there's a lot more focus on modularity of software, being able to deploy things post launch, right? And so a lot more satellite programs that you see being built are including something that they're calling them app stores, right? Software app stores for the satellite kind of fleet or environment, or for that family of types of equipment or flight software, whatever it is, right? And so the Space Force might make um, five different satellites for five different missions, but you could make a software that works across all five of those. And so instead of having to recreate that software and sort of dial it in just right for every different satellite, you now get the modular, kind of cloud, think software as a service, cloud based aspect of, and I don't care how your stuff works. Just give me an API, give me some way for my software to talk to your software, and we're good to go. Right. And everything else will just kind of tweak and balance out, post event. Let's just get it running and then we can tune it after. But the hard part used to be tuning it so that it could run. Now you get to do it the other way around. You almost guarantee that it's going to run, and then you just tune and tweak what you need to once you're deployed into the satellite. Again, great
nice.
idea. You don't have to get in at year two of a 5 year design phase to be on board. You can show up year two after launch. And if there's a dire security need, we could be responsive to that. And that's just a totally new paradigm. That was not, even 5 years ago, that wouldn't have
Yeah.
been a concept. So huge, big kudos to the Space Force for understanding that modular development and deployment that brings small businesses into the fold, right? It gets us because we don't have 5 years to work with a big prime for a payday and wait, forever and ever and ever to do all this development and get a launch. Like we can build something and find a place for it to sit and work, and we can get that life cycle done so much faster now. So it's good for us from the small business. It's good for the military from the acquisition speed to need, right? Those things are improved just dramatically. So we're really excited to be in this era of development with the Space Force because that's how they're doing business. So I
And
came from the opposite, and I'm really encouraged to see where we're at now.
that is so awesome. And are you seeing that kind of pick up as a trend? Are you seeing a lot more people adopt this type of philosophy and leaving a little bit of room for updates like that,
Mhm.
even post launch?
Yes, and the size and weight and power arguments of space that are still very restrictive. And man, the more I look into like what I think is going to have to be fairly resource intensive software that we're building, but then understanding the resource constraints, that's not keeping up with anything that's happening on the ground. Right? Resource constraints in space are still serious, like they're real. But even with that, there's enough. I think the cost to build compute and its power consumption have gone down enough that most satellite operators can build in a little bit of wiggle room, and it's not breaking anything in their engineering tolerance or engineering budget to be able to make the rest of the functions of the satellite work. And so again, great for folks like us that need to fit into that little extra space and maybe even have to share that space and take turns using resources. But if we can get the mission done, it's opportunity to get access and do something that just, again, just a couple of years ago would have never been a possibility.
That is great. I'm encouraged to hear that too. I mean, I'm a big fan of off the shelf components and having universality and being able to just plug and play as your needs might change. So I'm encouraged to hear that. That's really
Mhm.
good. And kind of related to this, when we had talked earlier, you told me a little bit about how you guys can do some testing for other folks and how you've worked a bit with Redwire and with Big Bear AI,
Mhm.
and that you are able to test components right now before they get integrated to other systems. Can you tell us a little bit more about that?
Sure. So for CROO development, we ProofLabs recruited Big Bear first, and for any of the listeners, check them out. BigBear.ai is the name of the company. BB.ai, and they are publicly traded. They're doing a lot of AI development that's not all DoD or space focused, but they had a project that they ran a couple of years ago where they did some proof of concept on the similar kind of problem set that CROO is answering. And so we recruited them into this project based on their proof of concept work. And when we linked up with them, that's how we got this award to do the software development for the Space Force. So they're our primary resource to train our machine learning and AI algorithms that are part of CROW. And then Redwire is our partner for doing modeling and simulation. And I'll be sharing an image with you. We have a Moonlighter spacecraft built as a digital twin. And for folks that don't know, Moonlighter was the target for Hackasat. So if you're familiar with this, environment or part of the industry at all, the Hackasat competition was a multi-year competition that was run by the Air Force Research Lab to allow partners and investigators and researchers from all over the world to interact with satellite hardware and software. So we use that as our target, and we have modeled that up. And so we're attacking a digital twin version of Moonlighter, and Redwire is our resource to do all that modeling and engineering for us. So, yeah, we're really happy to be working with them because internally we couldn't generate that level of expertise, and then have the kind of the resource backstop behind those experts to say whatever they need out of their tool chest, they'll be able to go get it. So bringing those well resourced and talented folks in to help accelerate our timeline was is the only way that a small business like us can really get traction and get that going. But never mind that the companies have great brand names and great reputations.
Mhm.
They had the right talent and the resources as well. So super excited to be working with them because that's we need that level of professionalism to get something like this built for the military.
Wow, that's really cool. That's fascinating.
Oh, and just I did want to mention we do have some services available right now that ProofLabs is solely responsible for. We
Please.
have Crow is a product, but we can do bench level analysis for vulnerability analysis in the lab. We can take a piece of hardware or software and run it through really an application based kind of penetration test. So a lot of people think of a pen test and they're looking for software bugs. I'm more looking for ways that I can force the system to misbehave, or that I can force, something like a gap or an error, a race condition, something that'll break through more of a functionality problem that then becomes a security entry point, right? And so that's the type of analysis that we do, is set it up in the respective environment that device should operate in, but then start to sort of throw a lot of different scenarios that are not your standard hacking scenarios. And if anyone's doing anything with space, or even the things that are kind of tangential to space, but that protect space networks, that equipment is can come into the lab here at the Space ISAC, and we can do those evaluations. So we issue a report based on NIST standards, and of course any remediation options that we think they could use to improve their product. We've done that for a handful of tools, both hardware and software, and not to there's nothing's perfect, right? We haven't had an engagement where we haven't found something useful that they're able to take and incorporate to make a better product. So I would encourage anybody that's you're just not quite sure what I know that it does what it's supposed to do, but how many things can it do that it's not supposed to do, right? That's We can help you answer that question.
Yeah,
Yeah,
helping answer the "I don't know what I don't know" questions.
right, right, for sure. And it's
And
exciting, right? People,
yeah.
whether it's, I don't know, as the CTO, someday my product's going to go through this type of evaluation. And I kind of don't want to be in the room when they come back and tell me what all's wrong with it, right? I don't want to hear it. I do want to hear it because I want to fix it. But at the same time, man, you just gave me a bunch of work, right? And so I know that I'm doing that for somebody else where they have to go back to the engineering, drawing board and work something out. But that's where the value's at, right? That's the bang for the buck. So, and so far we've been able to give that value to all of our customers. So.
That's awesome. And are you guys doing the same type of work for your AI model? And this actually it leads into another question. Are you creating your own AI model, or are you already basing that off of some other API that's already available and tweaking it
Mm,
to your needs?
this is a full from scratch development on the AI piece. All
Cool.
the back end is really from scratch. And then I saw that you have an image. We have some mock-ups done of our front end, but we are going to deliver a user interface and a threat intel user interface as well. So APIs will be how the different components, the back end to the front end to the threat intel, speak to each other. But everything is really being built from scratch in house right now.
Yeah. Here's that example of that right here. And I love your guys' example how you put Vanguard 5A. I saw that the first time and was like, "What? Is that even still available to get any system?" But nonetheless, this is a great example of showing, hey, this system has something weird going on. This system has something weird going on,
Yeah.
and to look for more information to figure out what's going on with it.
Yeah.
So yeah,
Yeah,
I
that's a
would
mock-up, of what the user will eventually have. And then I want everyone, that's listening to understand that we know on the ProofLab side of the conversation that screen real estate in the space operations floor it's a big deal, right? It's a premium. Everybody has a dozen computer screens and they're completely packed with windows that they need to do their job, right? So we don't think we can compete for a couple square inches on your screen, right? We understand that we have to hide, we have to be in the background, and that only when we create an alarm are we going to now override some of the other screen real estate. But when we create an alarm, you really can't ignore it, right? Everything else that it jumps up over the top of, it really does become secondary now because you're being hacked. And so all the other health and safety stuff kind of doesn't matter until you can put this fire out, right? So, but
100%.
we're aware of the environment we have to integrate into, and we're also building the option that there's going to be some suites of software out there where we just need to be able to get built into what they already can display to the user. And we understand that the format may be that we just co-opt our way into someone else's user interface. So lots of different ways to get this job done and not be demanding or intrusive on what's already a really intense environment for a satellite operator.
That sounds like a good system and a good plan. And even though I'm not a satellite operator, I'm very curious about seeing that type of information. And would certainly be interesting to see if there's a way to be able to communicate and turn back on some of the old satellites that are either in graveyard orbits or have just been defunct for many years, and if
Mm-hmm.
there is a way to do that.
Mm-hmm.
Um, but yeah, this is all very very interesting stuff. Um, there was a couple other things that I wanted to ask, and there was one other question from the chat room that is very specific technology case here.
Mm-hmm.
Let me get back and find this real quick. Bear with me.
I'll
This was
cross my
from
fingers that I can answer it. We'll see.
We'll see. We'll see. And if you can't, that's perfectly fine. We're
Sure.
not trying to push that. But Jacob asked that does this work from any operator system? Like, can I use this with OpenC3 or YAMCS, yet another mission control software,
Mhm.
or would it override that?
Mm. Yeah, this is agnostic to whatever your primary flight software is or your command and interface software. This can live outside of that main chain of how you do your control and how the commands get staged. Because we're sensing stuff that's happening on board, we're kind of outside of that path, so we get to be agnostic to whatever the user interface is for those parts. We are using. Cosmos, a version of OpenC3, in our simulation environments, but it doesn't really matter to us, what each flight operator has, because where we're sensing and where we're producing results can happen external from that. There are ways, of course, with Cosmos and some of your other open source software that we could configure and have basically a configuration file, and that may be the way we deliver to some of those users in the future. Is that, hey, you got your Cosmos right now, but then you could take this open source software and add the little ProofLabs package, and then that'll put some graphic inputs into your screen right there. So that's a phase 2 or 3 piece. We got to find a customer that needs that, but we should be able to do that for them.
Awesome. Aside from the Space Force, is there anyone in particular? Like, do you have a wish list of who you would want to work with?
Mm-hmm. We do. There's for me, I'm from the intelligence community, and so I want to get back into the protecting government, classified systems, and I'm very focused on the warfighter's mission of what they need to do with these satellites. But the outside of that, there are some satellite big dogs out there that we want to work with. For me, the geosynchronous satellites that handle a lot of backhaul and a lot of bandwidth, and have that big, regional stare mission. People think everything about LEO right now, like just because that's where SpaceX and all the proliferation is happening in low Earth orbit, right? But for me, I want to go after the big satellites that have really complex missions that live out of the geosynchronous belt, because they last for a long time. They serve a lot of customers. They serve commercial and government all on the same bird, right? And so, I'd like to go for some of your what we would consider legacy operators way out there on the geosynchronous belt, because those assets are also very hard to replace. Low Earth orbit satellites, there's probably something already planned to get up there and replace it in the next couple of years. Like there's a glide path for refresh over and over and over again. But once you get something parked in a location in the geosynchronous belt, you want it to last as long as possible, right? And we're talking 15 years, right? And so I would really like to be protecting those long term assets that have a lot of like high value mission associated with them. For me, that's what I care about the most. And then, commercial people don't realize just how much the United States government relies on commercial space bandwidth to get their job done right now. Like not even in the future, not with future proliferation, just right now. And so protecting things like Inmarsat and Global Star, those aren't even U.S. like focused companies, but the government uses those as backhaul bandwidth, and protecting those is really critical for the intelligence community and the warfighter. So, it might seem like it's not SpaceX, it's not the super hot thing that's going to launch 50 satellites next week. You're talking about something that's been on orbit for 5 years, but I see that as the asset that needs the most help. And so that's where I would like to work.
Do you see ways too that you would be able to help those types of satellite operators identify degradation and risks that to be able to avoid things like exploding batteries? Like if you see a certain level of degradation, like hey, we know that you had another year and a half, 2 years that you had planned for this satellite, but this component or that component is getting to a dangerous level, and it's time to put it in a graveyard orbit, bleed it out, and make sure that this doesn't cause a problem for your neighbors.
So there are other software companies out there that are doing health and safety monitoring like what you're talking about. And so there are some
Okay.
other products out there that can do exactly what you're talking about. Here's the real answer is that this sensor can, what we're working on could do both. And so it's possible that we start to see indicators of changes. And while we can clearly classify them as not a human created fault, it's still a way to sense a change in something that you maybe couldn't see happening otherwise. Or again, that secondary effect. Well, my battery drain is starting to have issues. And now I realize that actually these motors don't turn with as much torque as they used to because they can't draw as much power as they used to. Like those are the things that we would start to put a little more clarity into for that operator that otherwise they might not be able to see. So we could help with that. It's not what we're designed for, but in the end, it's a flashlight makes light. It doesn't matter where you shine it, right? And so we may find ourselves to be really really good at that predictive analysis just as a byproduct of what we're doing.
Yeah, that would be excellent.
Mhm.
I mean, that's certainly the biggest complaint that I hear of having too many systems, too many things spread out, and you know, that everyone wants to be able to have everything in one place and
Mhm.
not have to look at so many different systems and have something take them by surprise as
Yeah,
well. So,
yeah.
yeah.
Or, as I said earlier, if you're the satellite operator and you got 15 screens and all these different inputs, there, I hate to say this, I mean, this is how we do things as humans, right? There'll be one that misbehaves and it causes alarms when we, you lose confidence in its alarms, right? You lose confidence in that pop-up. And then it becomes a like every day, oh yeah, it's 9 o'clock. Yep, that's the alarm that it gives at 9 o'clock every day. You just start ignoring some of it, right? It's the alarm that cried wolf. Those things exist even in classified satellite networks where there's just some workaround and we just expect like degraded performance. And people build those workarounds and then they just like they never, two or three people rotate out and now we don't even remember how it worked in the first place, right? Like what did it ever do when it worked properly, and we don't know, but we just know every day it throws this alarm, we turn it off, and then we do this, right? And there's those kind of broken
Wow.
dependencies in all sorts of satellite systems out there. And so we want to get rid of that. I call that like risk and tech debt all rolled into one, right? Well, we definitely want to help people understand how to stop duct taping the answers back. Stop duct taping the satellite back together and then just gluing another note to the desk that tells the operator ignore the alarm at 9 o'clock, but trust all the other alarms all the rest of the day. That's a bad place. That's a bad way to be doing business, but it
For
exists, and so we
sure.
want to help get rid of some of that.
Wow. Well, good. Good. I'm happy to hear that. Oh my goodness, I just noticed that we've already been going for an hour. How are you
Man,
doing on time? Are you doing okay?
I'm doing fine. Yeah,
Okay, cool. I
yeah.
do want to ask you some of our kind of generic questions that we like asking everybody. First of all, do you have a favorite space shuttle?
Um, I do. It's the I had to look it up, and it's the era from the early '80s, right? The U.S. spacecraft from the early '80s that were the multi-tiered rocket launches, and then they had mainly the nose cone up at the end, right? So like '70s into '80s, I guess the old Apollo ones, right? Before the
Like some of
bigger
the old Titan
spacecraft ones,
launches and stuff?
yeah, yeah. And those I would say because just that's when I was a little kid, and so I was like, when I fell in love with how cool space was and the astronauts go to space, how cool is that? And I think I was maybe 5 years old. I grew up in Texas and we got to visit, we went to Houston and I got to go to the NASA museum there before I can really remember all of it, right? But I know that I left there with a toy that was a multi-part rocket. And so that multi-part rocket that had the little capsule on top and it had these little plastic astronauts like printed in there, that was what to me, if I was ever going to be an astronaut, that's how I'd end up strapped in a capsule and like blasted on the rocket like that. So that's what I thought, right? And never would I have thought that we're come forward to today. How many launches happen all the time? How many different types of rockets can get different types of vehicles into space? That wasn't a thing back then. And so yeah, that's just what I fell in love with was that multi-staged rocket with the capsule on top.
Nice. Do you have any favorite space probes or interplanetary missions?
I guess I'm just the same as a consumer. I've been blown away by all the deep, Hubble and newer imagery of super deep space, being able to see very, very far into the detail of things that are even close to us. So I am just as much a sucker for a really cool deep space image as anybody else. And so I'd say the Hubble and the super cool imagery satellites for taking pictures of the stars. That would be my favorite thing of what happens in space. I know that we do more life focused and life like human centric things in space, but that one, space is all about awe and wonder and like capturing the imagination, limitlessness, right? And so I like to look out into the limitlessness. I'm experiencing what's happening on Earth right now, right? So I don't need more pictures of this.
That's great. That is great. Over the years, as you have followed things, have there been any canceled programs that you wish had flown?
Mm, I guess I again, I wish we had done all this Golden Dome stuff that the Star Wars efforts from back in the Reagan era. Um, Regardless of the military aspect, I wish we had done that hard push on a technological advancement back then and really developed the things that were inspired by that, presidential administration and his desire to do that. So I guess for things that were described to come about but then never did, the old Star Wars, I wish that had become more relevant and the technology had really become into what we know today, because then we'd have so much more advancements in all the other other aspects of space. So I feel like there was a good idea to inspire a big technical leap forward, and then it just kind of didn't happen.
Okay, that's a
Yeah.
good answer. I like that. Um, well, here is, I mean, you've answered a lot about, cybersecurity and why this is important, and I really appreciate it. You've helped me and hopefully our audience to understand these risks a lot better. But the big question that I always like to ask everyone is, why space? Why are you doing this?
Mm-hmm. Well, as I mentioned, growing up as a kid, I was very interested in space. One, I thought maybe I could be an astronaut someday. As you want to be a firefighter, a policeman, a cowboy. Astronaut was my little kid fantasy job. And then as I got into high school, I realized that doing anything in the space industry was going to require basically a math degree. I'd have to go get a bachelor's degree in just math, and then I could specialize in some other, more scientific thing. And that was the deal breaker right there. I said, I get A's in math, but I don't want to do math for my job. And so I kind of left it. But I was always inspired by basically the book Cosmos and the TV series Cosmos from Carl Sagan back in the day. That opened up my mind to thinking about all things science, but it was all related to astrophysics. And so that being able to sort of observe things on in my world around me and then mentally bring that back to that astrophysics kind of science problem, I've been doing that since I was like, I don't know, I got that book, The Cosmos, when I was probably 10 years old, and read it. And I don't like reading books, but I was wrapped up in that book, right? And so ever since then, it's just been this kind of underlying tone for me that if I'm going to do anything scientific, if I'm going to do anything that's exploratory, if I want to invent something, I want to do that for space. I want to be a part of the story that this humanity's kind of reach for the stars. And even if my name's not printed at the top of the list anywhere, I'm not Dickie Hancock, signing off the Declaration of Mars. If I don't do that, that's fine, right? But I'd like to know that when I look up, that I did something there, that there was some work associated with it, and so far, all the stories that I have, I can't tell anybody, right? All the cool stuff that I've done with space, I did in a classified way. And so now I get to do this in a way where I get to have a website and I get to tell people what I'm working on. I get to talk to you and I get to share these ideas and this knowledge and collaborate and do that in an unclassified way. This is really what I always wanted, in any part of my career to be, if I was going to work in science, and I get to do it. I've realized that. So for me, this is just a realization, accidental, long, winding journey that's brought me to being able to do something that even 5-year-old me would have, I dreamed of. So here we are.
That is great. That is great. That is a great answer. Thank you very much. I appreciate that. Jacob agrees. Amen, sir, he
Yeah.
says.
Yeah. Yeah. I'm just glad to be doing it. So thanks for giving me a chance to say all that.
Absolutely. Well, before I let you go, was there anything else that you wanted to discuss or talk about?
Just the classic business plug stuff. We're in development. We're applying for further bids and opportunities to do more work for the Space Force. We are in our venture capital push to do our seed round right now. So anybody that's interested in future development opportunities in space, we're looking at what our next round of proposals are going to be. We're shifting a little more towards radio frequency protection on the C2 uplink stuff now. Seems like some of the demand, we're not abandoning anything we're doing now. It's just going to be an additional part of our feature set in our platform. So,
Sure.
and then, yeah, if there's the right type of investment group out there that's heard any of this and wants to be involved, we're open for that as well. So,
Well, they can find initial information about you guys at prooflabs.space.
Yes.
That's a great place to start. But what would be another way, other than just going through the contact us section there? Is there another way that people would be able to get in touch with you directly for that you're willing to share?
Yeah, LinkedIn is really my primary comms channel for folks that I, don't have email addresses with. If you go look me up, Dick Wilkinson on LinkedIn, I'm the only Dick Wilkinson on there, I think. If you Google Dick Wilkinson, there's like 50 of us, and they're all British dudes, right? But I'm the basically the only one that comes up on LinkedIn. So I do, check me out over there. I also produce some videos over there that are little science tidbit videos that get a lot of traction and they're real popular. So yeah, please check me out on LinkedIn and feel free to shoot me a direct message and we'll collaborate.
Awesome. Well, thank you so much, Dick. Thank you very much for talking with us today and educating us and help enlightening us to how serious this type of thing really is. And obviously, myself and a lot of us over here, we wish you the best of success, and hopefully, we can have you on again sometime in the future when and hear about some updates. But yeah,
Yeah.
definitely wishing you all the luck, and very grateful that you were able to tell us about all this stuff today.
Well, thank you, Mike, for having me on the show, and thanks everybody over at your production for hosting this type of content. I'm glad you're doing it.
Certainly. All right. Well, with that, I think I will let you go. Thank you guys for being here, and we will see you again next time. Keep moving onwards and upwards, everybody. And don't forget, ad Astra to the stars.